Hello and welcome back to Arts Tutoring for physics this time. This time we'll be going over vector math and components of vectors as well as angles of vectors. Last video we went over vector qualitatively. What does it mean? What does it represent? This video will dive deep into the math of vectors. First, let's analyze vectors using trig. Okay, so you should be confident with the trig here. If you're missing fundamentals of algebra 2, then I would recommend you to go check that out before you look at this. A vector, if you drew it on an x and y axis, imagine if I drew a line. I labeled an angle here because the line is this angle away from the x-axis. Makes sense? And then I said this line has a magnitude of v, okay? Or magnitude is basically the size of the value, right? The length. You know that from the last video. Size or value. Now, this line is going to be a vector because it has a magnitude as well as a direction. This angle represents a direction, right? It can move up or down or right or left or whatever. But it's a direction. How far away am I from this axis? So we can analyze this vector in multiple different ways. If you come over here, right, to this picture I draw here, imagine there's x and y axis, okay, 30-degree angle. Now, this vector over here has two components, an x component and a y component. Component just means part, okay? So the components in question here are, if I use different color to represent them, this is Vx, and this is Vy. Vx is the x component of vector. Okay, x component of the vector, which means how far did it travel in the x direction? Because a vector travels in both directions, right? X and y. Vx is how far it travels in the x direction. Vy is similar thing, but y component. How far does it travel in? If I use a different color, yeah, in the y direction. Okay. Vy. It's good because the vector travels in both, right? Now, if you use an angle theta, so, for example, imagine this is in 30, right? Imagine just an angle, some theta angle. Sine of theta is going to be equal to what? Vy over opposite over hypotenuse. So this is V, okay? This is the magnitude V. So if you wanted to find Vy, wouldn't it just be Vy is equal to V times sine of theta, right? Over here. Similarly, cosine of theta is going to be adjacent over hypotenuse, or Vx over V. So Vx is going to be equal to V cosine theta. So that's how you find the horizontal component or the vertical component, knowing the V value, or basically the magnitude. So if I gave you 20 meters, if I said the vector's magnitude is 20 meters per second, okay, and it's an angle 30 degrees from the x-axis. So now I'm going to erase this stuff so you can see it better. It's just a bit more, yeah. 30 degrees. Then how would you find the Vy component and the Vx component? Well, we know Vy is equal to V times sine of theta, right? So Vy is going to be equal to 20 meters per second, because that's a V, times sine of theta, which is 30 degrees. Pretty straightforward, right? Sine of 30 is 1/2, so it's going to end up being 10 meters per second. Always remember units, okay? Always remember them. And then Vx is going to be 20 meter per second times cosine of 30 degrees. Same thing, v cosine theta. So it's going to become 20 meter per second times root 3 over 2, which I believe estimates closely to 17.3 meter per second. Now, these are two of the big four vector equations we're going to need, okay? There's two more that also play a very fundamental part in vectors. So you're halfway there. These are the other two. V is equal to square root Vx squared plus Vy squared. And theta is equal to arctangent Vy over Vx. Now, where do these equations come from? Because obviously I don't just want to give you an equation and expect you to memorize it, right? I'll show you where it comes from. So, for example, if you look down here, if I had a vector v, we know that this is vector Vx, this is vector Vy, the components of v, right? How far v moved in the x direction and how far it moved in the y direction. So if you use the Pythagorean theorem, because we know this is a 90-degree angle, and we know this is theta, if you can say that v squared is equal to Vx squared plus Vy squared, right? Because isn't this just a right triangle? Vx is a squared, and then Vy is, you can just represent it as b squared. It's actually b, and this is actually a, right? Not b squared and a squared, but you can just see it like that. And all of that is going to be equal to c squared, or the big hypotenuse, which is vector. So this equation comes straight out of that. Okay? And then you can obviously just take the square root to get Vx squared plus Vy squared. Okay? V is equal to square root of Vx squared plus Vy squared. That's how you find the magnitude of a vector. That's the size of a vector, okay? How much value does it have? How big is it? And then for the other one, same example. Let's take a vector, theta here, Vx, Vy. We know that tangent of theta is opposite over adjacent, which is Vy is opposite over adjacent, which is Vx. So if you want to find theta, can we just do theta is equal to arctangent, or tan to negative 1, of Vy over Vx. That's how you find theta. Now, you have to be a bit careful here, okay? Because the thing is, if you look at this example, if you want to find theta, we know we can do tan of theta, or we can just use the formula, right? Which I just showed you how we got. Theta is equal to arctangent Vy over Vx, 8 over 6. But the thing is, if you also have something, if you had a graph that looks like this, negative 6, negative 8, but this would still be 10, right? Because it's positive. Square roots can be negative. The magnitude also can be negative as well. So, I mean, it's just a size, right? You can have a negative size. Now, how would you find this theta? Well, you can just say, arctangent of Vy over Vx. Vy is negative 8 over negative 6. But see what happens. The negatives cancel out, and you're left with just regular arctangent of 8 over 6. So that means the direction of this vector is the same as the direction of this vector. But this one is positive. It's on the positive quadrant. It's on the first quadrant. And this one is on the third, right? So that's why you want to be careful, because arctangent of 8 over 6 is for two values, because tangent is slope, right? If you extend this line, both this triangle as well as this triangle have the same slope. So if you plug in arctangent of 8 over 6, you get this answer, this theta. But for example, if you're looking at this triangle, then what are you going to do? If you plug in arctangent, you still get this theta. You're going to add 180 to this theta. And you see why? Because you need to flip it 180 degrees here. because this is a continuous straight line, right? How do we flip an angle completely or find the opposite of that angle? We do plus 180. So theta plus 180 define us down here. So how do you know whether you do this or whether you don't do it? It's all, you have to look at them, right? You have to look at the components and you have to see which quadrant they're in. According to that, you can check your answer and you can choose your answer, right? Because, or you could plus 180 degrees to change it, to represent it accurately. So that's how you deal with these kind of configurations. Also, there's another case, right? It's not just the positive first and the fourth quadrant. It's also, for example, if you had, let me just get this out of the way. If you had a negative triangle, right? Not a negative triangle. I mean, it's on this quadrant, the fourth quadrant, not the third quadrant. Theta is over here. And if you have another triangle that looks like this, theta over here. If you do arctangent of this triangle, you're going to get a negative value, right? Because this Vy is positive, but the Vx here is negative. So you're going to get a negative Vy over Vx. And over here, what are you going to get? You're going to get arctangent of, but here Vx is positive, but Vy is negative. So this is going to be negative Vy over Vx. So you see again how you get the same answer. In this case, if you know that your Vy was positive, then you just find this, right? If you know that your Vy was negative, you'd have to add 180 to this. Or because, domains of arctangent, you're going to get this answer first. If you need to add 180, you can add 180 to find this answer. Because the domain of arctangent is negative pi over 2 pi over 2, right? Okay. So that's all that I wanted to make sure you're aware of. Now, let's have some practice. If you have this theta degree that says, we don't know what it says. We have to find that out, right? How would I find the angle of this? Well, theta is equal to arctangent Vy over Vx. So it's arctangent of 8 over 6. And you have your calculator, you know that's 53.1 degrees above the x-axis. And if you want to find the magnitude, square root of Vx squared, which is 6 squared, plus Vy squared, which is 8 squared, which just gives you 10. Now, the magnitude formula, this is just a cool derivation, right? It's not really like too theoretical. It's just something cool to know. If you do Vx, Vx is V cosine theta. So if you square that, and you square Vy, which is V sine theta, you'll be left with V squared times cosine squared theta plus sine squared theta. And you know that this is going to give you V squared, because this is 1, right? If you know from pre-calc or algebra 2. So just neat little identity. So now let's practice some vectors, okay? Because these are the fundamental foundation of physics. A 15 meters, and obviously I'll have better detailed question on artslearning.com and on a PDF. So if you want to check that out, go ahead. 15 meter per second vector sits 60 degrees above horizontal. Find Vx and Vy. So Vx is going to be 15 cosine 60 degrees. And Vy is going to be 15 sine 60 degrees. Right? So if you pull out your calculator, cosine 60 is 0.5. So Vx would be 7.5. Vy would be 15 times sine of 60. And sine of 60 is 0.866, right? So times 15, 12.99. And remember your units, meter per second, meter per second. A 40 Newton force points 25 degrees below the horizontal. So like that. The magnitude is 40 newtons. Find both components and Vy is negative. Okay. So in this case, if you wanted to find out Vx, Vx is pretty straightforward, 40 newtons. Actually, let me show you Vy first. 40 newtons times sine of something. But you can't say sine of 25 because this is below that x-axis, right? 25 is above that x-axis, regular 25. So this would be negative 25. Or you could do, this is a bit risky, but you could do sine of 25 because the magnitude is just going to be the same, right? It's just that this is a negative. And then you can make sure that you remember to put the negative. But if you don't trust yourself with remembering that, you can just use this, right? Sine of negative 25. So if I calculate that, that's negative 16.9. 4 newtons. And Vx would be 40 newtons times cosine of 25, or 40 newtons times cosine 25. Yeah, so it would just be 36.25 newtons. Okay? And obviously, make sure the negative over here. Given Vx equals negative 5 and Vy is equal to 12, find magnitude and angle. So magnitude, so let me just draw the vector, right? Vx is negative 5, and Vy is positive 12. So it's going to look like that. So magnitude, we know that's equal to square root of Vx squared plus Vy squared, which is equal to 13, because this is square root of 169. So magnitude is 13. We don't have any units, so we can just keep it as it is. Okay? Adjust the raw arctangent into the correct quadrant. So if you're finding the angle, obviously we start with arctangent of y over x, right? So 12 over negative 5. Plug that in. And I get negative 67.38 degrees. Isn't that over here? So you remember how I said you have to shift it by 180, right? Because, right? Arctangent gives 2 values. If you put it in a calculator, it only gives 1 because of the domain restriction. It can give you 2 values. But you have to figure out how to make it get put back. Okay? Which is you add 180. So what is 180 plus negative 67? That's 112.6. 2 degrees. Okay? And if you don't want to put it in, if you don't want to have negative 67 here, you could do 360 minus 67, and then you could find this angle, and then you could subtract 180 from that. But I think this is easier, so I'm just going to use that. But sometimes you're not allowed to use negative values, right? Negative angle values, so just keep that in mind. So verify that the magnitude equals 5 with the Pythagorean identity. Okay, components 3, 4. All right, so we know Vx squared plus Vy squared has to be equal to V squared. 25, 9, plus 16. So pretty straightforward. We know this is true, right? 25 is equal to 25. It's a great job. And then that's it for vectors. Next video, we're going to be going over average velocity and speed, as well as position time graphs. So look for that, right? Keep your eyes out for that. And also feel free to give me a like and subscribe if you think I helped you. And check out my website, awesomeLearning.com, for more practice problems, PDFs, or videos. Completely free, by the way. See you in the next video.